Today we will be studying about midpoint theorem. This theorem states that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and half of it. What it means is, you can understand with the help of this figure. This is a triangle ABC with E as the midpoint of AB and F as the midpoint of AC. So if we draw a line joining E and F, then this line EF will always be parallel to the third side, which is BC in this case, and the length of this EF will be half of BC. This is what can be represented of this theorem in a short form. If E and F are midpoints, okay, this condition will be provided to us. Then what we can write is EF is half of BC and EF is parallel to BC. We can come to know the use of this theorem in any sum if information given in the question is that midpoints of any two sides of a triangle is provided to us. So the line which we will be getting by joining the midpoint, we can write it parallel to the third side and also write it half of it. Now you will be seeing how to get the proof of this theorem done. So we will follow the procedure of writing, and so first we will write what is given to us. The given part is that in this triangle ABC, E and F are the midpoints of AB and AC. Then we will write what is to be proved. We have to prove that this line EF is parallel to BC and this line EF is half of BC. So that's what is written here. Now for getting the proof of this done, we require a construction to be done. And that construction goes like this, that this line EF is produced to a point G such that EF and FG are equal. And then this point C and G are joined. So that's what I have written here, that produce EF to a point G such that EF equal to FG join CG. Now let us see the procedure of doing the proof of it. First of all, we will be taking these two triangles, that is triangle AEF and triangle CGF, and prove them congruent. So first of all, we have AF equal to FC, which I have written here. The reason is given, that was provided to us. Then these two angles, that is angle AFE, this angle, and this angle, that is CFG, are equal, that is by vertically opposite angles. And then we have EF and FG equal, because we had taken here in this construction that they are equal. So we get the triangle congruent by the rule SAS. So once these two triangles are congruent, I can write AE equal to CG by CPCT and name it as equation 1. And then this AE is also equal to BE. I have written here, that is equation 2 that was given. Now if I take these two, both this CG and BE are equal to AE. So from equation 1 and 2, we get CG equals to BE, which is written here. So this part, CG and BE are equal now. Because the two triangles were congruent, I can also write angle EAF, this angle, equal to angle FCG, this angle. So I have written here this one. And then if we take a note of these two angles in the figure, they are coming over here and over here. And these are alternate angles. And when alternate angles are equal, we get the lines parallel. So I wrote here, we get here AB parallel to CG, and the reason for that has to be written since alternate angles are equal. On this line only, we have this line BE. So I have changed that AB to BE. So I wrote also BE parallel to CG and as equation 4. So what did we get here? BE and CG as equal. And we are getting here BE and CG as parallel. So these two lines are parallel as well as equal. That happens if the figure is a parallelogram. And so I write here BCGE as a parallelogram because same pair of opposite sides parallel and equal. So now if this is a parallelogram, I can write BC and EG as parallel and equal. So I wrote here EG parallel to BC and EG equals to BC. On this line EG only, EF is a part of it. So I change this EG to EF parallel to BC, and then this EG can be written as 2EF. This EG can be written as 2EF because we have EF equals to FG. So now this 2 will be taken that side. So I get EF equals to half BC. So parallel proved, half proved. Sum is done. So it ends with a QED, which for me is quite easily done.